Hello friends. So for today we're going to be talking about section, I don't even know what section we're on. I can't read it. 1.6 maybe on polygons. So let's get started. So here are a couple examples of polygons. So there are a few characteristics of a polygon that you need to know. So here they are. Polygons do not have holes. No holes. Okay. Polygons also do not have curves. That means your fave shape, the circle, is not a polygon. And then the last thing you need to know about polygons is that their sides cannot overlap. Okay? All right, so we've been talking a lot lately about naming things. And so to name a polygon, you're going to use all the vertices and you're going to write it in consecutive order. So that word consecutive just means back to back. So for example, this is a pentagon. It has 5 sides. When I name it, I'm going to write the word pentagon. And then I'm going to name it in consecutive order. So you can pick whatever vertex you want to start at, whatever point, whatever letter. So I'm going to start at M, just for fun. And then you have to go around in either a clockwise or a counterclockwise rotation. You can't say pentagon M, P, C, J, F. You can't just jump all around. You have to go around, okay? And again, you can go around either direction, but you have to be consistent. So I'm going to call this pentagon M, F, P, J, C. Okay, we'll talk more about that in a few more examples later on. Okay, there's 2 different types of polygons you need to know about. The first one is called convex. And the second type is called concave. Okay, so a polygon can be either convex or concave. Here's the difference. If a polygon is convex, that means that all of its points, all of its vertices kind of poke out. Okay, not very mathematical, I know, but they all point out. So to decide whether or not that's true, if you can't look at that and tell that they're all pointing out kind of, then you can extend the sides and all of the extensions lie outside of the figure. So here's what I mean. I can just make all the sides a little bit longer, and you'll notice that none of those sides cross through the middle of my polygon. Okay, that's what makes this a convex polygon. Concave. If a polygon is concave, it caves in on itself. Concave. Do you see where that's happening right here? This vertex, it was this one in this picture, is now caving in on the shape. So if you go around and you're not sure, is it convex, is it concave, and you start extending all of your sides, so far so good, but as soon as you get right there, wait a second, it went through the middle of my shape. I can do it again right here. Wait a second, it did it again. Okay, so this is concave, this is convex. All right, names of polygons. And I probably should have pre-written this in, but I did not. So here we go. I'll write quick. Names of polygons. So we're going to name polygons based on the number of sides and angles. Obviously, a 3-sided shape is a triangle. The proper term for a 4-sided one is a quadrilateral. A lot of times people will tell me rectangle, square, something like that. And you're not wrong. Those are 4-sided shapes, but their overarching name is quadrilateral. A 5-sided shape is a pentagon. 6 is called a hexagon. 7 is a heptagon. 8 is an octagon. People usually know that one, like an octopus. 9 is called a nonagon. That one's kind of weird. Nonagon. 10 is a decagon, kind of like a decade. I'm writing decade. Decagon. Can't talk and write. And then the last one says n. What I mean by that is just some number of sides. So maybe there's 47 sides. We're just going to call it a 47 gon. So I can give you any number and you can just stick gon behind it, and that's how many sides it has. These first 10 I do expect you to know. You'll see those words on test, homework, that kind of thing. And I'm not going to say, hey, there's a heptagon. Oh, by the way, it has 7 sides. I'm just going to say a heptagon, and I expect you to know that it has 7. So do make sure you know those if you don't already. Okay, So another thing you need to know about polygons is they can be what we call regular. If a polygon is a regular polygon, it meets 3 criteria. First, it has to be convex. We just talked about the difference between convex and concave. So if you look at this polygon right here, you can see that all of its vertices are pointing out. None of them are caving in on the shape, so it is convex. Second thing is that all the sides are congruent. I'm done writing that word. Remember, I'm going to use my symbol. So when I look at this picture, hopefully you're thinking to yourself, but we don't know if all those sides are congruent. And you would be right. So I've got to let you know for sure they're congruent. So remember, we mark congruent sides this way. And the last thing it needs to happen for it to be regular is that all the angles are also congruent. So again, I've got to tell you that for sure. We don't assume anything in geometry. And now I can say with confidence that this is a regular polygon. It's convex. All the sides are congruent. All the angles are congruent. All right, so let's do a couple of examples of that. Check these out. So it's asking us to do 3 things. It says name the polygon by its number of sides, convex or concave, and then regular or irregular. So first we'll start with the number of sides. We're going to use a fancy word for the number of sides. So this polygon has 1, 2, 3, 4, 5 sides. That makes it a pentagon. Convex or concave, well, I can clearly look at it and tell it's not caving in on itself. So it must be convex. And regular or irregular. Let's revisit that one again since we just talked about it. If it's regular, it's convex, which it is. The sides are all the same, which they are. The angles are all congruent, which they are. So this is a regular polygon. All right, look at the next one. Some of you may be tempted to tell me that's a star. And it is. That's good. But I want you to tell me, I want you to name it based on its number of sides. So we're going to count its sides. The star has 10 sides, making this star a decagon. Convex or concave. Hopefully when you look at that, it's screaming concave at you. It's caved in all over the place. All of these points have been brought inside the shape. So this one is concave. And then for regular or irregular, remember the first thing that has to happen for it to be regular is that it must be convex. This is concave. That automatically makes this an irregular polygon. It does meet the criteria of the other 2, where all the sides and angles are congruent, but since it's concave, it is an irregular polygon. All right, 2 more slides. Perimeter and area. I'm going to go through this one quickly. I know you learned perimeter and area in like elementary school, but just for fun, perimeter is where you add all the sides together. So if you wanted to add 2.3, 2.3, 4.6, and 4.6, you would get that your perimeter is 13.8 centimeters. And then for area of a rectangle is base times height, length times width, however you learned that. And so area would be equal to 4.6, the base, times 2.3, the height. So the area of this rectangle is 10.58. Remember when we do area, you write your units as centimeters squared. Okay, I'm not going to go through the circle as quickly, although I think I could. Usually when I get to this point in my notes and there are students in front of me, they break out in song. So those of you that went to Petal Middle School, I'm sure you know some kind of area of a circle song. Pi r squared sounds like area to me, something like that. And so you're right, that sounds like area to me too. Area is pi r squared. Circumference is 2 pi r. Let's talk about the difference here. Circumference is kind of like perimeter. Okay, if you could have perimeter of a circle, it would be called circumference. That's telling you the distance around the circle. Remember, area is telling you the distance inside the circle. That's the difference. Remember, the R in these equations stands for radius, and that radius is the halfway part across the circle. Remember, if it goes all the way across, it is called the diameter. All right, so let's work these real quick. So the circumference is equal to 2 times pi times the radius, which is 4. So that gives me a circumference of 8 pi. If I ask you for an exact answer, 2 times 4 is 8 pi. Or if I ask you for the approximate or the rounded answer, it would be 25.13. I forgot my units. Inches. And that's your approximate or your rounded answer. All right, let's look at area. Same thing. I'm just going to plug into my formula. Pi times r squared. If I want my exact area, I'm just going to do the 4 squared, so 16 pi. Remember, area is inches squared. That's my exact area. And if I type that in my calculator, that would give me 50.3 inches squared is my approximate. Y'all, my allergies are killing me. I'm so sorry. Okay, 2 more examples. Cute little word problem. Mr. Smith has a circular fence that encloses an area with a diameter of 12 feet. So I'm going to go ahead and make myself a note. If the diameter is 12, that must mean that my radius is 6. So it's a circular fence. We've got a circle. Whoa, that's a bad circle. And the radius is 6. And if it's a fence, are we talking about circumference or are we talking about area? So fence, it's just going around the outside of my circle. That's definitely circumference. So I'm going to start by writing down my circumference formula. And we want to use the same fence to make a square fence. So I need to know how long my fence is. So I'm going to use my circumference formula. I want to know how far around my fence or how far around my yard is that fence going to go. So here goes. 2 times pi times 6. So that gives me an approximate circumference of 37.7 feet. All right, let's keep reading our problem. We want to use the same fence and we want to make a square fence. What's the maximum side length of the square? So our total fence is 37.7 feet long. But if I want to make that into a square fence, I want to know how long would one side be? Well, we know a square has 4 equal sides. So doesn't it make sense that if I take my total fence length and divide it by 4, I can get the length of one side of my square. So 37.7 divided by 4 leaves me with 9.425. And we're in feet for one side of my square. All right, last one. Find the perimeter of a square that has an area of 36 square centimeters. Okay, so we're talking about area of a square is 36. So area of a square. So area of a square is base times height. We said was a rectangle. A square, more specifically, is just the side squared. Base times height. The base and the height are the same thing. So 36 is equal to side squared. So that must mean that one side is 6. The question, though, says, well, find the perimeter. Well, if one side of my square is 6, it's a square. All the sides are the same. So that means all my sides of my square are 6. The perimeter, 6 times 4 sides, must be 24 centimeters. All right, that's all for today. See you later.